Hey there, this is Professor Duresh, and this is part 4 of our 4-video series on dividing polynomials. In the last video, we learned polynomial long division, and if you haven't seen that video yet, I do recommend that you watch it before this one. In this video, we're going to talk about synthetic division, which is a version of polynomial long division that only applies when the divisor is a linear binomial with a coefficient of 1. So I'm going to write that and say it again. The divisor must be a linear binomial with a coefficient of 1. And so I believe this is called a monic binomial, but I'd have to look up the vocab. Basically, your divisor has to look like x plus some number or x minus some number for synthetic division to work. So let's take a look at one of the pop problems we originally used polynomial long division to divide, and we're going to repeat that process with polynomial synthetic division, and I want you to take a minute to compare the two for yourself. So this would be example 5. And the problem is to divide x squared plus 9x plus 20 by x plus 4. Now I am going to set up the long division, but I'm not going to redo the long division. So if we were doing it using long division, we would write x plus 4 and a division, x squared plus 9x plus 20. In synthetic division, we have a few additional steps and a different way of writing the problem. So step 1, we are going to solve the divisor equal to 0. And what that means for us is we're going to say x plus 4 equals 0. And we're going to subtract the 4 to the other side, and we get negative 4. In polynomial synthetic division, we put negative 4 in a corner. Then we flip our division bar, and different professors have different ways of writing this. This is my preference, but you may see other options when you're looking up synthetic division online. Next is we're going to lay out all of the coefficients and only the coefficients. So the coefficients of x squared plus 9x plus 20 are 1, 9, and 20. To perform the long division, we're going to bring down the leading coefficient. I do have to write it in shorthand. So that means we just bring down the 1, unchanged. This step is very similar to before. We are going to multiply the coefficient to the updated divisor. One times negative 4 is negative 4. Now in long division, this is where we would subtract. But because we've taken the divisor and solved it, the sign has already switched. We don't want to subtract, we actually want to add. Finally, we just repeat that process until we run out of coefficients. 5 times negative 4 is negative 20, and 20 plus negative 20 is 0. This down here is our answer, but we have to bring back our x's, our variables that we removed in order to perform the synthetic division. So if you remember, we originally had x squared plus 9x plus 20. If you take x squared and divide it by x, you're going to be left with x. Similarly, if you take the next term, 9x, and divide it by x, you're going to be left with 9, or just a constant. So our answer is 1x plus 5. Generally with synthetic division, it is much faster than long division, but we usually need to see it more than once for it to really click for us. So we're going to do this again using synthetic division, but I'm going to give you a longer problem so that you can see more steps. Here we go. This will be our last example. This is example 6. And we're going to divide 5x to the 4th plus 2x squared minus 8x plus 2 with x minus 4. Number 1, we solve our divisor. X minus 4 is equal to 0. X is equal to 4. Then we set up our synthetic division. The first coefficient is 5, but we have to be aware at all times because this goes from 5x to the 4th to 2x squared. So we're missing an x cubed. And if we don't put this placeholder in synthetic division, we won't get our division correct. So then we get 2, -8, and 2. We should actually make a note, 0x cubed, because it's important. Now we go through the process of synthetic division. It starts by bringing down the 5. Then we multiply 4 times 5, and then we add. Then we do 4 times 20, and then we add. Oh, these numbers are giant. Then we do 4 times 82. Was that 328? And then we add. And then we do 4 times 320. And then we add. I'm actually going to put this last number in red because that number is the remainder, and we can reinforce how we write remainders because how we write them doesn't change when we change our method for division because the problem is still the same problem, we're just solving it in a different way. Finally, we need to bring back our variables. So we started with 5x to the 4th, and we divided by x, which means our first variable should be 5x cubed. It's 1x less than it was before we divided. Then we have 20x squared plus 82x plus 320. And try to think back to video 3 where we talked about how to write the remainder. The remainder goes in the numerator of a fraction, the denominator being the original divisor. And that is our final solution. So thank you for watching this 4-part video series on polynomial division. At this point, you really need to practice and reinforce these skills, and you can use these videos as reference if you feel stuck.